Hi, this is Jack at Jack's Transmissions. Today we're going to show off our new 3.5 shift fork, all billet, 100% designed and made here in-house at Jack's Transmissions for the DCT470, EVO 10, SST Ralliart transmission. So it's the dual clutch unit. So this unit is really incredible. It took some pretty advanced equipment to make this, and quite honestly, we put everything into this that we could think of to make this a solid, reliable piece to replace the junk that has been plaguing us for years in this platform. Let's take a closer look. First, let's take a look at the OEM. So OEM fork is just flawed everywhere you can imagine. So the first are these plastic guides. These guides hold the fork in place in the case as it moves up and down and helps guide it, not only up and down, but keep it in position. So these plastics are weak, they become brittle in time and will break. And look at the area where it meets the body here. It's got just this little open-ended rivet here, hollow rivet, and then look at the stress riser in here. It gets thinner as it goes up to the meat of the guide. It's like they just want it to break. It's just very poorly designed. It's just not really well done. And if these ever break and you need to replace them and you're trying to pull them off like another fork, they always break. They're so brittle and fragile. They're just a nightmare to deal with. So that's the first negative. Second negative are all these crimped areas in the fork. This area here that holds this is known to come loose, where this will move around. The magnet arm here, where it's crimped, will come loose and move around. Even this detent plate on here, which you would think there's no way that's going to have a problem. We've even seen those come loose, where this crimped area will come loose here, and this will move around, and then you'll get shift fork errors. So all of these will cause shift fork errors. And then to top it all off, you have this epoxied area here where essentially the shift fork position magnets are glued to the fork arm here, and in time, the epoxy degrades and everything starts to move around. Now the mechatronic in this has a sensor in the tower of the mechatronic that senses the magnetic field from these magnets. And if they move more than 1 millimeter, you're going to get a shift fork error. So you have like a negative and positive polarity here. If it moves all the way one direction, it'll be like closer to 5 volts. The unit will know, okay, it's in this gear. Then you go down all the way down to the bottom, it'll be closer to 0 volts. Okay, it's in this gear. And if it's in the middle, it'll be between those two voltages, and it'll know it's in neutral. And if everything is all moving around when it's not supposed to, when the TCM is expecting it to be in neutral or a gear position, you're going to get shift fork codes. So it creates confusion in the TCM where it will limp out. So we have all of that, and then to top it all off, these pads here that make contact with the sleeve, has got to be the smallest surfaced area I've ever seen make contact with a sleeve in an automotive application. This is just awful. It's like they just want it to wear out and fail. So a lot of negatives here with this fork. It's just not very good. We go here to this piece. This piece are what the hydraulic pistons make contact with. And hydraulic pressure will push the fork down one direction. There's a piston on the other side. Hydraulic pressure comes up to the back of the piston, moves the fork in the other direction. In time, as everything's made out of plastic, look at the witness marks on the piston. You see that wear on it, where it's beginning to cave the plastic in, and it's actually digging into the plastic. That's because this area is so narrow, and it's not making full contact with the plastic all the way around. It's only a very narrow area. So really, if you were to design something to fail, this is just a beautiful example of that. There's just so many failure points in one piece. So now we go to our fork. Our fork is just incredible. It's just so well engineered all the way around. So we look at the plastics now. You have meat all the way through here. There's no stress riser, no weak point. The OEM, look at how weak that is. Look at that. And now look at ours. Nice and robust all the way through. And then on top of that, instead of using a rivet and keeping this area weak, we put like a little notch inside this assembly here where the hole would be in the body. And what will happen is that little tab will snap this into place as we press it into place. It's a beautiful pressed fit as it goes in. It's absolutely perfectly accurate. We get the perfect pressed fit as we go in, and then you get a nice little click as the tab engages the hole and holds it into place perfectly. It's not going to go anywhere. So it's a simplified design with less, parts to fail, and it's a much meatier and stronger design too. This plastic has a lot more flex and shock resistance than the OEM. We're very, very proud of the engineering on this. It's been just dead solid reliable. Now the rest of the fork, as you can see, is all one piece all the way through. Nothing's riveted or crimped together. It's just all 70-75 billet, not 60-61, but superior 70-75. Really, really nice. Look at the shift fork magnets, all integrated into all this meat right here. It's just absolutely beautiful. And with the magnets, look at the resolution on these magnets. Look at how nice and square that is. Here, let me try to get it without a glare. See that? That is like a really nice, accurate magnetic field there that keeps the mechatronic and the sensors happy. OEM, not so high resolution, but you can see it very closely matches OEM. We're basically right on the money there. So shift fork magnets, issues with this are definitely a thing of the past. You're not going to have any problems with the shift fork magnets here. Now, what about the piston contact surface? This area here, where the piston's putting a lot of pressure on the fork, I mean, you have synchro resistance, you have harmonics, you have all kinds of things as a force up against this piston as it pushes the fork up and down to engage, disengage a gear, or even put it in neutral. Look at how huge this is. This is just massive. It's going to take advantage of all of the real estate on your piston. So you're not going to have a narrow area where OEM, see how narrow OEM is compared to ours? OEM is so narrow, it basically starts to eat into your piston. Ours is nice and wide, extremely robust, and it gives it a much more, gives it much more contact. And look at that, it's almost exactly the size of the piston. So that way you don't have to worry about your pistons wearing out at the tips, failing, and then causing shift fork errors where you have to tear the trans apart and do it all over again. We've really tried to think of everything here. So now last is the shift sleeve contact surface on the fork. I mean, look at this. This right here, just from experience, we found this design is one of the best designs out there you could use for a shift fork. It's less prone to smearing and wear than any other design we've ever seen. This is incredibly robust, and it makes contact with the sleeve all the way around. Top and bottom, all the way around. So here we go. It's just a beautiful, just a nice snap into position where, we've really tried to extend this out as far as we could to really take advantage of, the contact area with the sleeve to give us just an absolutely wonderful area where it's not going to wear out. It's, as you got so much more surface area than OEM. I mean, look at that. Look at the difference. So it's not just this right here, it's making contact all the way around with the whole thing. So yeah, you're not going to wear this fork out. It's just, we're so happy and so proud of how this worked out. 3.5 fork, 3.5 shift fork, DCT470, SST, EVO 10 Ralliart,